Hi everybody, good afternoon. It's 3:30, so we're going to go ahead and get started with our live webinar today. Today's surprise STEM topic is paper circuitry, and we're going to have a chance to learn how to use this technique in all different subject areas at all different grade levels. So my name is Mary Morgan, and I'm coming to you live from the Perot Museum. We're so excited that you're able to join us today. And stay tuned all the way through the end of the webinar. At the conclusion, we'll give you a link to a survey, and if you complete the reflective survey, you'll be able to earn 2 CPE credits for today. So let's go ahead and get started. If you have any questions as we're going through the webinar, if you're viewing this on your computer, on the right side of the screen, you'll see a chat. You can open up that chat and ask questions as we go through. Or if you're using YouTube on your cell phone, at the bottom of the screen where you're viewing, there's a little bar that will say Top Chat. You can click there and it'll open up that chat bar for you. And I'll answer those questions as best I can and as quick as I can as we go through today. All right, so first thing we need to start with is, what is a paper circuit? So as you can see on my table here, I have some different views of paper circuits, some different options. And let me zoom in on those so you can see those a little bit better. So these are just card versions, and you can see that they have little LED lights that are lighting up. And that's because we've added some electricity, created a circuit on the back of the card, and so we're creating an extra dimension to our artwork and to various projects that students could do in the classroom. Now, the best part about paper circuitry is that not only are you creating a functional circuit on a paper base, but you're using materials that are incredibly versatile, so they can be used for art projects, they can be used for presentations. As you see here, we've made cards, they can be used for games. There's all sorts of different uses. The other thing is that the materials are completely affordable. So there's versions that you can do using materials just straight out of your house, things like aluminum foil. And then in this case, we've used a few more specialty materials, but they're still extremely, extremely affordable. So the first thing I want to talk about a little bit is circuits and electricity. And so what is a circuit? Well, a circuit is simply a way to move electrical energy from one place to another. The idea is that we have all this potential electrical energy that we can use to do work, but we want to have a way to get that electrical energy from its storage place, in most cases a battery, to the place that's going to do work. For today, that'll be a light bulb. And so what I have here up on the screen is an example of part of a circuit. The big silver thing in the middle is the battery, and then the kind of goldish coppery color stuff is indeed copper wire. And I've marked the voltages on our circuit. So our battery is a 3-volt battery, and that battery is going to be producing a maximum of 3 volts. It won't always produce exactly that, but that's the maximum we can get out of that battery. Then I've marked the other end of our circuit as 0 volts. There's no electrical energy there, and so therefore there's no voltage. So what's going to happen is electricity always wants to move from a higher voltage to a lower voltage. So in this case, I've added some arrows that show the direction of the electrical energy movement. So the electrical energy is going to move from the 3 volt through that copper wire towards the lower voltage, which is 0 at the top. Now the thing is that in order for electricity to move, we always have to have some sort of conductor. And so on our diagram here, that copper wire that you see, that's going to be our conductor. Conductors are typically metals, although there's other things out there that will conduct electricity, like water. In our case today, we're going to be using entirely metal and metal wires as our conducting sources. So what I'm showing you here is just a simple closed circuit. Closed meaning that everything is connected and electricity is currently flowing through this circuit. So the battery, which is the silver dot down there in the bottom left-hand corner, that is what's providing the electrical energy. And we just learned that electricity travels from positive to negative in a circle. Now, the interesting thing about the positive to negative flow of electricity is it's actually a little bit of a misnomer. Benjamin Franklin was the first person to suggest that electricity flowed from positive to negative. And that convention had just been kept for years and years and years, and engineers use those terms, and electrical people who are working with electricity and researching that use those terms as well. More recently, we've learned that electrons are what is actually moving through our system, our circuits. And so those electrons are negatively charged. Well, what does that mean? Well, instead of electricity actually flowing from positive to negative, the electrons, which have a negative charge, are flowing from negative to positive. Now, in the grand scheme of things, if you're looking at flow of electrons, that is important. But as long as we're all talking about electrical circuits in the same way, and we understand that positive to negative is not actually what's happening on a science level, then we're good to go. And so what happened was, because Benjamin Franklin's suggestion of positive to negative had just been used for so long in science and engineering circles, they kept that same naming convention. So just keep in mind that when we say electricity flows from positive to negative, the truth is the electrons are flowing the opposite way, but we still say they're flowing positive to negative. It's a little confusing. Some may need some time to wrap your head around that, but we're going to keep saying positive to negative because that's what we've traditionally done. So in our circuit here, we said this was a closed circuit. And so you can see that we have our energy starting in our battery, which is 3 volts, which is right over here. And then that electricity is going to flow from the positive terminal, in this case the top of the battery, all the way through our copper wire in the direction of that yellow arrow, up through this little green thing at the top. And this little green thing at the top is just an LED bulb. And then that electricity is going to continue to flow from the LED bulb out to the opposite side of our circuit, around, and then the electrical energy is going to flow back into the negative side of the battery. And we've indicated that the wire is on the bottom of the battery in this case by using a lighter orange square. Now, if we were to remove something from this electrical circuit, for example, if we were to take that LED light off of there, that would create what's called an open circuit. And an open circuit just means that no electricity can flow. We can use open circuits to turn different products on and off. So when you flip a light switch on, you're closing a circuit, and when you flip a light switch off, you're opening a circuit and stopping the flow of electricity. So a little bit about the batteries that we're going to be using today. We're going to look at a coin battery for our purposes, but up here on the screen I'm showing you a 9 volt and then just your normal alkaline AA, AAA, C, D type batteries. Every battery that we're going to use today is working on DC current, and so they each have a positive and a negative side. So a 9 volt battery, what I call the flowery side, or that kind of like squashed down side, that's the negative, and the side that sticks up is the positive. On your AAA, AA batteries, the side that has the little point sticking up is always positive, and the flat part of the battery, what we typically think of as the bottom, is going to be the negative. Now you may be wondering, why do we care about positive and negative on the battery? Well, when we start looking at building a circuit today, we're going to need to make sure that our electricity is always connected positive to negative, so that our electrons can properly flow through there. So if we aren't sure which side is positive or which side is negative, we might get things hooked up backwards, and that would create a big problem when it comes to a closed circuit. If you hook things up the wrong way, you have 2 things that could possibly happen. You could end up with something that's like a short circuit, and we'll talk more about that in a second, or you could end up with a circuit that doesn't work at all. Both of those, not situations that we want to encounter. So why do we care about circuits? What's the importance? Well, most of us live in homes that have electricity, and we are able to just flick that switch and turn a light on. And the whole reason why we need electricity is to do work. The light is using the electrical energy, converting that to energy that's able to actually do work for us. And so what you see here on the board is a picture of the circuit we're going to build today. And this circuit is a closed circuit that's going to light up a light bulb. Now, when we add a light bulb to our circuits, that light bulb is doing work. and we call that light bulb that's been added the load. So think about if you're hauling something in your car and you put a bunch of stuff in the trunk, you've added a load to your car. When you add the right amount of load, your car still gets really great gas mileage performance, but you're still hauling a ton of stuff in the trunk of your car. That's the ideal situation. But think back to a time when you maybe overloaded your car. You put too much stuff in the trunk and in the back seat. Maybe you were moving off to college, or you were moving to a different house and you had to load down all of your stuff in there. What happens to your gas mileage? Well, in my experience, the gas mileage always goes down. And that's because the car is having to work harder to get that load pulled from one place to another. Well, it's very similar in electrical circuits. If we put too much load on a circuit, then we can actually slow the current down. And when we slow the current down, the products that we have connected to that circuit don't work near as well as they're supposed to. We can also have the opposite problem, however. Unlike our car, when we take the load out of the trunk, the car gets great gas mileage and life is good. Having too light of a load on an electrical circuit can cause a big problem as well. So for example, up on the screen, what you see is a very, very simple circuit, and it has absolutely no load. It's just a battery attached to some copper wiring. We say that this is a very light load, and you would think, well, that's great because we're getting a ton of power. The problem is that what happens here, the battery is going to continue to put energy into the system. When the battery continues to put energy into the system, then it creates basically what amounts to an infinite loop of electricity. The problem is that the battery can't keep up with an infinite loop of electricity. And so the battery is going to continue to put more and more electricity out. But because it can't keep up, it's eventually going to, at best, run the battery down quicker than it's supposed to. Or, at the worst, in this particular example, we could actually burn up that copper wire, which could start a fire. Now imagine, if you will, that we've gone through and we've added a load to this. So let's say that we've added an LED light. Well, if we don't have the right voltage as compared to that LED light, so for example, if that 3-volt battery is too large, too many volts to power that LED light, so for instance, a very small voltage LED, what can happen is that we still have an instance here of a simple circuit with an LED light, but we would be putting too much power through that LED bulb. And if we continue to put too much power through, we can also burn out the LED bulb. Again, that could cause a fire, and that could result in some, really bad things, especially if you think about, like, you plug an iPhone into a plug. If it's getting too much voltage, then that iPhone, or whatever brand you use, is going to potentially burn out. You could actually destroy your electronics. When we have a situation like what we see up here where the load is too light and so the circuit is continually flowing and we're not using up that power, we call this a short circuit. So how do we prevent these in our houses? Well, most people, if you go through your house, if it's a new enough house, and I mean, we're talking new enough in the last, 50 years or so, way back when electricity first started to be used in homes, this didn't exist. But most houses today have been brought up to code. In fact, I can't think of any examples where houses haven't been brought up to code. And so somewhere in your house, you're going to have what's called the circuit breaker box. And that circuit breaker is designed to prevent these short circuits. So if a piece of wiring or anything else in your house starts to reach that point where it's overloaded, then that circuit breaker is going to flip and it's going to shut off the electricity and prevent those wires from burning up and preventing house fires. All right, so that brings us to the next step. What do we use paper circuits for? What are they, and how do we build them? Well, a paper circuit is simply just a circuit that is built on a piece of paper. So as you can see, we have some cards over here, and these cards have the circuit built into the back. This one doesn't want to come open. Let me zoom in here so you can see this better. So here's our paper circuit card. As you can see on the front, it has a little light. And then when we open up the card, what you see on the back is a circuit. And so there's different materials that you're going to need to make these cards. And these materials can be translated to any other paper circuit that you might be interested in creating. Now, how are we turning our card on and off? Well, we're simply using the idea of open and closed circuits. So when I unfold the corner of my card right here, our circuit is open, which means that on the front the light is off. But when I fold the corner of the card up, this part of the copper wiring is going to touch our battery. And when that happens, I've closed the circuit and our little light bulb is lighting up. And so you might be able to see this a little bit better on our little reindeer card here. You can see his little red nose is lighting up, and that's because we have the corner folded, creating the closed circuit, and it's paper clip shut. Right? Oops. That card apparently didn't want to stay on the table. So here's another example of a card that we've done with this circuit. And you can see that light lighting up as well. And we're going to have these templates for you in Edmodo, so if you're interested in doing this in your classroom. All right, so what are we going to need to build our paper circuits? Well, we're going to need the template. That's the card. And so today we're going to do the happy birthday card. And on the back of this card, what we've done is we've actually drawn in a template for you to show you where to place the battery, where to put the copper wire, and where the LED bulb should go. You'll also need some conductive adhesive copper tape. Typically this copper tape comes in rolls. So here's a roll of copper tape right here. And this copper tape is pretty affordable. You can get it at various online retailers, and my rolls, I think I got 5 rolls for about $10. So it's pretty affordable. They came in 50-foot rolls, and for this particular size. You can get skinnier copper tape, you can get wider copper tape. For what we're doing though, you know, just the kind of like medium sized, this is about 1/4 inch, works really, really well. The next thing that you're going to need are some LED lights. And LED stands for light emitting diode. And so I just bought a big box of them, and they come in all sorts of different colors. You zoom in here so you can see that. And the various LED lights come in various voltages. So make sure that you get the right voltage for the battery that you're using. You don't want to get lights that require more voltage than your battery, because then they will never light up. But you also don't want to get LEDs that are too low in voltage, because you risk a short circuit like we've talked about previously. And so if you do get LED lights that are too low in voltage by accident, you can always buy resistors and put those into the system to help lower that voltage that's coming through the light. But we have some that are 2.8 to 3.2 volts, so we're good to go for today. Okay. The next material you're going to need is a battery. For paper circuits, I like to use the flat lithium batteries that are 3 volts. Again, here's a picture of one. They're just coin batteries, and these are great because they don't take up too much bulk on the back of your card. And then finally, you're going to need just some basic office supplies. So a pair of scissors, you're going to need a thumbtack or something else that you can use to punch a hole through the paper. And it needs to be a small hole, and you'll see why in just a minute. And then you're going to need some just Scotch tape. All right, so to create our greeting card, the first thing we need to do is we need to lay the copper tape down onto our card. Oh, and something I forgot to mention. With the copper tape, you want to make sure that the adhesive copper tape you buy says that it's conductive when you purchase it. If it doesn't say that it's conductive tape, it won't allow that current to flow, and so you'll end up with a card that won't work. So always test it out after you buy it. Make sure you got the right stuff. Some of them, some of the copper tapes you buy are copper tape, but the adhesive itself isn't conductive. And so that also can create a problem. But just again, make sure that it says when you buy it, conductive adhesive copper tape. Okay. So let me zoom in here so you can see what I'm doing. So the first thing we want to do on our card is on this template, there are some double lines. And so we're just going to lay pieces of copper tape along these double lines, just like what you've seen happen up here on the screen. Okay. So to do this, I've already pulled the backing away from my copper tape. And when you're doing this, I would not rip all the backing off the copper tape straight away, because this copper tape has a tendency to like curl up on itself, and then it sticks to itself, makes a big mess, and becomes useless. So just leave the copper tape partly attached to the paper and peel as you go. So I'm going to start my copper tape at the end of 2 lines. I'm going to lay it down between the 2 lines all the way until I reach the other end. And then you can use a pair of scissors to cut it, or it breaks pretty easily on its own, so you could also do that as well. So as you can see, I've just laid down 1 line of copper tape. Then I'm going to lay down the next line, but I have to turn a corner. So when we get there, I'll explain what we've done. So I'm going to start at the bottom of my card, again going between the 2 solid lines. I'm going to peel up the copper tape until I get to the corner. Now when I get to the corner, I have to make sure that metal is always touching metal. If I were to break the copper tape off and then pick it up, turn a brand new piece and lay it down on top, the adhesive between the 2 layers of the copper right here would prevent the electricity from flowing, because the adhesive on my copper tape acts like an insulator rather than a conductor. So what I need to do is I actually need to fold the copper tape back so that metal is always touching metal. So you can see that in our picture up here on the screen. Right here, if you look really closely, you'll notice that there's kind of a triangle piece, and that's because I folded that copper tape back on itself. So what I'm going to do on my card is I'm going to peel a little bit of the backing off. I'm going to go right to the edge where I need to stop. Then I'm going to pull my copper tape carefully in the opposite direction that I need to turn. So I want to go this way with the copper tape. So I'm going to pull my copper tape to the left. And that's going to create a fold. Then I'm going to just use my fingernail and very carefully press that copper tape down and fold it back on itself. And then lay it down on the card. And again, cut or tear. And now we have all of our copper tape laid down. So now we have all of our wiring done. And if you wanted to create a more complicated wiring system, for example, like on this Christmas tree card, I didn't do it on this card, but if you wanted to put some different LED bulbs on each of the branches, you could do that. You would just have to do a lot more wiring on the back. And then you could actually use this in your classroom to talk about wiring in parallel and wiring in series, and have the kids maybe experiment to see if wiring in parallel or in series works better. And the other thing is that as you add more bulbs and they're pulling voltage, you're going to increase the load. And so therefore you could talk to your students about, is the amount of voltage on your battery enough? Do you need to add another battery? So it would be a great engineering design method. Just make sure the students really understand the idea of short circuit before you let them start playing on their own, so they don't accidentally short something out and create a hazard. All right, so back to our card. Since we have the wiring laid down, the next thing we need to do is we need to add in our LED bulb. There's lots of different types of LED bulbs that you can buy. You can get what's called an SMD LED light, and those are very flat, so they work great if you want just a really, really tiny flat piece so that you don't bulk up the front of your card. In our case, we're just going to use a regular LED lamp, and they're very, very tiny, so I am not going to be able to show you that real well on the camera, but you can see it up here on the screen. And on these LED bulbs, what we find on this particular style is that they have two metal, what we're going to call legs. And those legs are different polarity as far as being positive or negative so that we can have the electrons passing through them. So the long leg on our LED bulbs is going to be the positive side, and the short leg is going to be the negative. Now we know that electricity flows positive to negative. So if we come back to our card, my electricity is going to start here at the battery on top because the top of the battery is positive. Then that electricity is going to flow from positive, and the positive side will actually be here. So it's going to flow from positive through this piece of wiring all the way around. So this end of the copper tape is negative, which means that we have to connect a positive to a negative. In electricity, you always connect positive to negative, not positive to positive or negative to negative. If you do that, you won't get any sort of current flow. So since the long leg of my LED is positive, I'm going to connect that to the negative end of the copper tape. And then the short leg of my LED, which is negative, is going to connect to the other piece of copper tape. So that becomes a positive end. Then that copper tape goes under the battery, which is the negative side. And so we end up creating a complete circuit. So let me show you how I add the LED light to our card. This is where your thumbtack or something that will poke through the card comes in handy. I like to go to the front of the card to poke my hole because the template doesn't always print in the exact right spot where you might want that LED. So in this case, I'm doing a birthday card. So I want my LED light to be right at the top of the candle. So I'm going to use my thumbtack. I'm going to put it right where I want the LED light to go, and I'm going to punch a hole. Then I'm going to wiggle that thumbtack around to make that hole a little bit bigger. So let me zoom in here so you can see what we're doing. So again, just put the thumbtack in, wiggled it around. Then I'm going to go to the back of my card and I'll be able to see the hole. I know you can't see the hole I've made, but I promise it's there. And I'm going to insert my LED lamp at this point. Now on our templates, we've written long and short to help you identify what goes where. But if you forget, you can always look and think, okay, bottom of the battery, and so that would be negative, so this would be positive, which means that our short leg, the negative leg, has to go over here. So I'm going to insert my LED light through the tiny little hole. And it'll probably tear the card a little bit, that's okay. And by the way, I'm using 3mm LED bulbs. They come in different sizes. You can get 5mm and up. But I've just found that for these little cards, the 3mm has the right voltage and it doesn't put too much bulk on the front of the card. But if you're doing this with younger kids, you might want to get the larger ones. So once my LED bulb is through, I'm going to find my short leg and I'm simply going to fold that down. And then I'm going to go to the long leg. I'm going to fold the long leg down so that they touch the copper wire. There you go. Just like so. And then to keep them in place, we're just going to put a piece of Scotch tape on top of them. Now Scotch tape acts like an insulator, and insulators stop the flow of electricity. So if I wanted to add anything else, I would have to put it on here before I put the Scotch tape down to make sure that we always have metal touching metal. All right, So we've added our LED bulb that's now visible from the front. You can kind of wiggle it and adjust it as needed. So let me zoom in here on the screen for you so that you can see where we've added that LED. So the LED legs are up here. All right, so our last step in creating our card is to add our battery. So for our card, the way we've set this up, the battery needs to face up. And I've noted on the card, and again, I know you can't see this, but it will be on the template, that the positive faces up. So we find the positive part of the battery and we lay it down on the paper. We want to make sure the negative, the bottom side, is touching the copper wire. And then we need some way to hold this battery in place. You can't glue it down because if you were to put glue all over the bottom, again, it would act like an insulator and you wouldn't be able to conduct electricity through there. So instead, we're going to use a little bit of Scotch tape right on the top of the battery so that it holds the battery down, but it doesn't cover the whole top of the battery. So to do this, what I like to do is take a piece of Scotch tape and just rip it down the middle so that I basically end up with two halves of Scotch tape. Then I put one half of the Scotch tape on one side of my battery. And I want just a couple of millimeters of tape to touch that battery. So I have about 4 millimeters of tape actually touching the edge of my battery. And then I'm going to do the same thing on the other side just to make sure that the battery doesn't go anywhere. And at this point, it's okay if the tape crosses the copper wire because the copper wire is touching the bottom of the battery. So it's okay to insulate the copper wire from the top. So that wouldn't be a problem. Okay. So that's the setup on the card. All right, so we've now created a lovely open circuit. But how do we turn our card on and off? Like I showed you earlier, we have to close the circuit. We have to make this wire right here touch the positive side of the battery. So to do that, we fold the corner of the card up, just like so. And if we've done this correctly, when we close our card and press on the corner, we get a light that lights up. So, and I know it's hard to see because it's so bright in here, but that light's right here. So there we go. So off and back on again. All right, so that's how we create a paper circuit. In this case, like I said, we're doing a greeting card, and we're going to post the instructions for this for you on Edmodo, so they'll look like this. And so you'll have a walkthrough, and we've included some information about simple circuits as well as a picture of the circuit, and then step-by-step instructions with pictures on what you need to do. Okay, but what if you want to do something more than a greeting card? What else could you buy as far as conductive supplies to use this principle and translate it to other things? Well, you can, of course, like I said, buy different sizes of copper tape. You could work on creating series circuits or parallel circuits as well, using multiple light bulbs, and experiment with that. Some other things that exist out there now. This right here, and again, I know it's very hard to see, but this is conductive thread. So it just comes on a spool like any other thread. You put it through a needle, and then you can actually sew with this. So you could have the kids, create light up shirts. You could have students create stuffed animals that light up, or you could include some sort of a sound piece that you buy online and wire that in and have the kids have a stuffed animal that talks. So just a number of ideas that you could do with the connective thread. Some other supplies that you can buy conductive fabric tape. So copper tape is great when you're just staying in a straight spot and there's only like one fold. But it's very brittle when it is being folded continually, so eventually it will wear out along this fold on the card, and you'll either have to replace that or the card just won't work anymore. So if you want to do something that requires a lot of folds, you can actually buy conductive fabric tape. And the fabric tape bends and folds and moves, so you can wire things that are going to be getting a lot of movement. You can also buy conductive paints. They come in both just like roll-on, brush-on paint, so you can cover a whole area with conductive paint, or they also come in pens, so you can draw with conductive paint. Ink, the same way. They have pens where you can actually just sit there and draw a circuit onto a piece of paper or other medium. And like I said, you can get SMD LEDs, surface mount device LEDs that are very flat and tiny, and so those would create less of a bulk on the front of the card. They can also be wired into clothing using that conductive thread that we've already mentioned. So some ideas for your classroom. You could definitely use this for games for learning, and I'll show you an idea for that here in just a second. You could have your students create projects, both the experimental design piece that we've already talked about, as well as just show them the process and then allow them to take it where they will throughout the year. Some students may decide that they want to create some sort of clothing piece to present a project that has different points that light up. I could definitely envision like having some sort of really cool shirt that had like a map, and as you went through your presentation, you know, and you were talking about, say, different cities in Texas, you could have those different cities light up by closing different circuits on a t-shirt. So just some different ideas there. Musical instruments, there's an example, and it's at that Spark Fun website, which is right here at the bottom, where somebody has created a paper circuit musical piano. So it actually has touch buttons on it that you press and it plays music. You could do electronic art. So this is a great way to do some STEAM work. So if your students are creating an art piece, give them the creativity and allow them to expand that further. Something really neat is this poppables. And this is something that was done by a group of people, and they created these books that have these super intricate designs. One of them is planets, and so they have the different planets that are lighting up. Another one is flowers, so when they pull different tabs, it's like a pop-up book, but when they pull a tab, then that connects the circuit and causes that flower to light up. And again, another great way to do a presentation. So you can view that video, and I'll put those links in the description underneath the video once we finish today. And then the Spark Fun website has a huge just list that they've collected of different ideas to do with paper circuits. So that's a great resource, and again, I'll link that in the description as well. So like I said, I was going to show you some ideas on how to use games using this paper circuit idea. So this was a game that one of my students created one year as her class project. They had to match the levels of genetic organization, and so she created a matching piece where she wired this using just everyday household objects, and then you placed a sensor on the left side. So for example, you might place that on DNA, and then you placed another sensor on which picture you thought was DNA on the right side, and if you were correct, it lights up, and if you're incorrect, then your sensor doesn't light up. Now it sounds pretty complicated, but this whole idea and the creation of this is actually really easy. So I'm going to walk you through just briefly in our last few minutes on how to do this. So here's another example here. This is just a worksheet that was turned into an interactive matching activity. And the best part is that as the kids go through this process, they're checking their own answers. So you won't have kids constantly raising their hands going, am I doing this right? Did I get the right answers? They're checking themselves, which is fantastic. We also see a lot with students who have accommodations. A lot of their accommodations were that they got instant feedback. Well, you can't get more instant than a light that lights up if you're right and a light that doesn't light up if you're wrong. All right, so how do we do this? Well, the materials for this, like I said, just come out of your household kitchen. They're simple and straightforward. Grab them here. Okay. So what you'll need is a file folder or some other sturdy item. I like file folders because they store really well, and so you can just stick them in a file drawer for that unit, or in some sort of plastic shoebox storage system, and then when you get to that unit, you just pull them out and they're ready to go. And they don't even have to be new file folders. If they have writing on them, you can just go through and glue something on top of that to cover up the writing. You can cut off the edge. So every year in our permanent records department, they would clean out, and I would collect all their old file folders and save it to use for this technique. All right, so what you're gonna need for this is some aluminum foil. You'll need some copper wiring, and this was just bought at a big box store. You'll need red and black to make sure that you're wiring correctly. And I like the 26 AWG wire. You can get other size wires. I just feel like this one is the most flexible and pliable, and works best for this project. You're gonna need some wire cutters. You'll need some electrical tape, some masking tape, paper clips, some AA or AAA batteries, as well as the battery casing. And so this is just a place where you put your batteries in, and it has your positive and your negative wire sticking off. Some of these are AA, and they only take one AA. For example, on the back of this one is just a single AA. The one I have here today is 2 AA batteries. Some of them take AAA, so again, your battery just needs to match that. And then a pair of scissors. So, how do you set this idea up? Well, basically you take your worksheet or whatever you're trying to match, you place that onto the file folder, and you draw dots wherever you want your answers to be. So if we go back and look at our example here, let me go back to the student one. Everywhere that we need a sensor, there is a dot. And that dot's been hole punched. Same thing on our example here. The dots have been hole punched. So I would hole punch those dots first, lay your paper down on your file folder, and then draw some dots. And I've numbered them in the order of the correct answer. So, for example, answer 5 is on the top on the right, and then I've labeled it as the second from the bottom on the left. Now that's going to be super important, because when you start to create this, you want to make sure that the right answer is touching the right answer. So what you do is you just cut yourself some strips of aluminum foil, and then I like to fold them in half to make them smaller. And you want to, this one's really wrinkled, but you want to try to keep them as flat as possible and as not wrinkled as possible. You can experiment with this. I haven't found much of a difference between shiny side out and shiny side in when I'm folding. But again, you're welcome to experiment. And if you find something different, let us know. I'm always interested in ways to improve ideas. Okay. So then once you have your aluminum foil folded, then you're going to go back to your file folder, and you're going to tape that piece of aluminum foil down so that it goes from the correct answer to the correct answer on opposite sides. So as you can see, on the left side, it's touching correct answer 1, and on the right side, it's touching correct answer 2. And then I'm just going to use some masking tape to hold that in place. Now, since this foil is metal and we want it to conduct electricity, but we're going to have to layer multiple ones of these so that we can get the answers correct on each of the levels, you're going to want to cover the whole entire thing with masking tape before you move on to the next level. So what that looks like is this. So we've continued adding our metal strips, leaving the answer dot covered with metal, but not covered in masking tape, but everything else in the middle where the metal crosses gets covered in masking tape before you add the next level. So we continue to build that process until we're completely done and all of our answer choices have been wired. So it's basically a hamburger stack of foil, tape, foil, tape, foil, tape. If you really want to be super enterprising, you could definitely use copper wire for this as well and just lay the copper wire across instead of using the foil. This would be a great use for that thicker copper wire and would be a lot quicker because it has the adhesive. But you know, if this is something you want to do tomorrow in your classroom or next week in your classroom and you don't have time to get the copper adhesive tape, definitely go with the aluminum foil and masking tape. So once we have all of that wired, then we glue our question and answer page back on top, making sure that each of the holes that we've punched has metal showing through it. And then we just glue that down. I would recommend using like a white school glue rather than Elmer's glue, like an Elmer's glue stick, because the glue stick, it will eventually start to peel off, and you don't want your students to be able to like peel it up and see the answers and put it back down. And so that's how you create the playing board. The next thing you have to create is your sensor system that checks whether the students are right or wrong. And this is where the circuit comes into play. This would be a great activity for your students at the beginning of the year if you teach circuits that early, to go ahead and wire these for you, and then they can use them for the rest of the year as they're playing the games. So what you would do is you take your battery pack, and you'll notice that I've stripped the end of the wire here. I know it's not going to be visible, but just know that I've stripped the end of this wire off. And then I'm going to wire this part of the battery to a Christmas light. Now this is just an old strand of Christmas lights that we've cut and stripped the ends. So I'm going to make sure that metal is touching metal. And I'm going to kind of wrap the metal ends around each other, but then to make sure that it stays in place, that's where my electrical tape is going to come in handy. I'm just going to put a piece of electrical tape all the way around where I've wired, partly to protect those wires and make sure no one gets shocked, but also to help hold them together. Okay. So let me zoom in a little bit closer here. Okay. So once that's done, then you're going to have to wire in some sort of a sensor to close the gap. So to do that, I'm going to use paper clips and some more wire. So again, I'm going to attach another piece of wire to my Christmas light, just like so. Then on the end of that piece of wire, I'm going to attach that wire to a paper clip. And to secure that in place, and for safety reasons, I'm going to put a piece of electrical tape around that joint, just like so. You can put more electrical tape on up the paper clip if you want to create a better gripping spot for the students. It's up to you. You can also use bigger paper clips than I'm using. Then on the opposite end of your sensor, on this black wire, you can attach another black wire if you want to have more give and play. I'm just going to directly attach the paper clip. There we go. Again, more electrical tape. Okay. And so that's your sensor system. So what's going to happen, and then obviously you'll put batteries in there or it won't work. Got to have that power source for the voltage, right? Okay, so let me get this out of the way. So what we end up with is something that looks like this. Now, when I create my battery packs in my classroom, I don't attach them to the folder. This one's been attached just so we don't lose it. but I do like what you're seeing up here on the screen. I just used some stiff pieces of cardboard and hot glued everything down to that piece of cardboard. And so I use the same sensors for every file folder game that I used to play. And so the sensors just stayed in individual baggies in a cardboard or plastic shoebox. And then, like I said, I stored the file folders in unit folders. So what happens is when they get ready to play the game, let me bring this over here so you can see this better. What you do is you take one side of your sensor. So in this case, we're matching body parts. So we're going to touch one side of the sensor, the paper clip, to ear. And then we're going to find the ear on this particular model. So let's see. Oh, here's the ear. Oh, nothing happened. My light doesn't light up. Well, that must not be the ear. All right, let's try here. That also looks like might be ear. Oh, and I know you can't see it probably very well on the camera, but at this point, the little Christmas light up here is lighting up. And so it's telling me that yes, that is indeed the ear. And then I can keep going. So hand, and there's the hand, and it lights up again. So this is a great way, like I said, for students to be able to play games in class, learn something and check their work while they're doing it. It's a great test review piece, and it's a way for them to immediately check their own answers. So they're not sitting there wondering, did I get it right? Did I get it wrong? It's just a really, really fast way to do that. I also used to use these for quizzes. So I'd have students come up and match them for me, and I could check really quick whether or not they were getting it right or wrong. And these work for any subject. Again, this is a matching game. I used to do sequencing as well. So I would have a paragraph split apart, and that's what was on this slide back here. This is just a paragraph about engineering, and the students have to put the paragraph back in the correct order. So it required them to do some critical thinking, it required some reading skills, and then also I typically did it with content pieces, so they were learning some new idea or new content as they read through the information. Okay. All right, so that's all I have for you today. Hopefully you've gained some information that you can use in class about paper circuits and circuitry. Again, here's one of our adorable little Rudolph cards, and then we also have the extension idea of creating a classroom game. We're so glad that you were able to join us today, and if you'd like more information about the professional development workshops that we offer here at the Perot Museum, you can check out our website. We also have information there about our Kosmos Energy STEM Teacher Institute, and then you can email us anytime at teacherworkshops@peromuseum.org. We look forward to hearing from you. If you have any questions, we'll hang out in the chat for just a little bit longer, and then this webinar will be available for you to view going forward at any time that you want to. And the last thing we need to do is make sure you get your CPE credit. So let me get that put into the chat window as well. All right, so there it is. So if you'll just click on that link that I just put in the chat window, you can go to the survey for today and earn your 2 CPE credits, and we'll get those certificates sent out to you tomorrow. We'll also put that link for a limited time in the description box after we put this video online, and that way you can take that survey at a later date. Just know that after about a week or so, that survey is going to disappear, and you can still watch the webinar, but you won't be able to get your credit. So again, thank you so much for joining us today. I'm Mary Morgan, and I hope you've learned something. If you have any questions, don't hesitate to let us know. Have a great evening. Bye-bye.